If I take the 2 outside,
كان 25 دقيقة.
who would agree with me that this is right and who would say that this is not right? Sigma from K equals to 1 to N for 2K minus 1. I am saying that this is, the 2 goes outside because adding 1 plus 2 plus 3 plus 4 is the same as adding, so sorry, 2 plus 4 plus 6 is the same as adding 2 times 1 plus. ماشي؟ This 2 outside, we agree with this? Anybody disagrees? Yes? شايفها مش شايفها؟ 2 plus 4 plus 6 plus 8 is equal to 2 times 1 plus 2 plus 3 plus 4, right? So the 2 can take you outside. And the minus 1 is again a different summation. Yes. I am adding minus 1 K times. Okay? This would be equal to 2 times N plus 1 times N divided by 2 minus N. The addition of 1 N times is N. You agree with that? Minus 1, minus 1, minus 1, minus 1 N times is minus N. Yes? This is the summation that I started with or not? Do you see this one? This is sigma from K equals 1 to N K. This is the one that I just did. And it came out to N times N plus 1 divided by 2. Okay? And this is the 2. Stays outside, and this is what I just wrote here. 2 plus 4 plus 6 plus 8.
How you did this here at 5?
I am just simply substituting this to be N times N plus 1 divided by 2. And substituting this to be sigma from K equals 1 to N for the number 1. I'm adding 1 to itself N times. So 1 plus 1 plus 1 N times, this is N. Okay? فاهمين يا اخوانا مش فاهمين؟ اللي مش فاهم ها؟ I want to add the odd numbers. These are odd numbers, 1 plus 3 plus 5 plus 7 plus 9. I want to add them. I want to find a formula for adding these odd numbers. Okay?
ازاي المتتابعة؟ sequence 1
So this method
انا عارف انه
1 plus 1 plus 1 plus 1 n times. يا راجل يا وزين خربان. بقى 1 زائد 1 زائد 1 يطلع 1 وزين.
كنت واخد اشتراك رياضة تبقى جميع اليمين.
So multiply this out. So 2 goes with the 2. So this is n squared plus n minus n is equal to n squared. Okay? So, if we go back to the original one, so sigma from n equals 1, 2, 5 for 2n minus 1 is equal to 25, which is n squared. 1 plus 2, sorry, 1 plus 3 plus 5 plus 7 plus 9. Okay? If you substitute n is equal to 1 here, so 2 minus 1 is 1. If you substitute n is equal to 2, it's 4 minus 1 is 3. Substitute n is equal to 3, 6 minus 1 is 5. 7, 9, to add them is 25, which is n squared. N squared. How would I have a rectangle for this one? نرجع لحصة التنوين تاني. This one. One, 3, 5, 7. Okay? How many dots in this? 1. How many dots in this? This one 4. This one is 9. This one is 16. If I do another one, it will be what? 25. So if I keep adding odd number of dots, I will keep getting squares. Okay?
Is the rectangle or triangle is more easy?
This is just a way to visualize it. Whatever what other way you have to visualize is fine. Yes, sir. Can you add 2? Okay, I'll give you 1. Plus 4, plus 6, plus 8. Yes, if you have 300 terms, what would you do? ها؟ ماشي، ما هو القانون ده اللي عايزين نجيبه فن. هو ده بالظبط حضرتك القانون. هو ده. احنا هنجيب القانون. Yes sir. In the back. ها؟ عايز صوت بس. ها؟ n square plus, who would like to volunteer to do this one?
n squared plus
What would give me a formula for adding the even numbers? You added the odd numbers. Who would give me a formula for adding the even numbers?
n squared plus n. We can make this.
Okay.
We can make this one like.
صراحة حطوا له حد شوية. Thank you. So what we have just done here is that we got a formula. So right now, if I have any number of terms, I can simply plug the number n into that formula, and I will get, as opposed to just keep keep adding numbers. This is the answer to your question. N is the number of terms. N, the index, n that k is equal to n. AK, this is the formula for the kth term. Okay? I have n terms, each one of them is in terms of k. K is the running index, and the index starts at 1. Okay? So what are the even numbers? Even numbers are 2k. Odd numbers, 2k minus 1. Squares, k squared. Cubes, k cube. Whatever. Formula for the numbers, and he gave me some examples here. K over k plus 1, k squared over k minus 1, whatever. Okay? This one will give me 4 squared over 4 minus 1. And this one will give me 5 squared over 5 minus 1, and so on. Sometimes I can get a formula that will give me the sum of that series, and sometimes I cannot get that formula. For that course, we're not dealing with series. This is the only section that we're going to talk about series in. Okay, there is another part of another course that we're going to talk about series, geometric series, algebraic, converging, diverging, and so on. So I'm not going to talk about series very much today. لا يا فندم احنا بنجيب حاجات من اليمين والشمال كده عشان خاطر احنا زهقانين. ها؟ طيب. So right now, if I have a function that I would like to divide it into smaller and smaller intervals. So the first of these subintervals is x1, x0 and x1. The second is x1 and x2. And the k subinterval is x, k minus 1 and xk. This is the k subinterval. Okay? You will see where this is heading. If I keep putting smaller and smaller subintervals, then that integration becomes simply that summation, right? Because each subinterval has a width of delta x and a height of f of ck. Then that summation will be equal to the integration. This is exactly your question from the first part. This is to show you that that summation actually equals to the integration. So if I can evaluate that sum, we're not evaluating sums, by the way. Okay? This summation just to approximate the idea is that if you get many subintervals, each one has a height that is determined by the function f of x, then in the limit, when this goes to infinitesimally small subinterval, then that summation becomes an integration process. So now I have a process called summation and a process called integration. In this case that we are talking about, they came out to be equivalent. So the rectangles approximate the region between the graph and the x-axis. So the area under the curve, in this case, this is a negative area, this is a positive area. Why? The height here, f of x is negative, so this is a negative area. F of x is negative, this is negative area. This is positive area. The magnitude of the function will determine if this is a positive area and a negative area. If, on the assumption that that function has the same amount of negative area as positive area over the interval from the beginning of the integration to the end of the integration, then integration actually can become 0. If I have some negative, if I'm integrating sine x, for example, from 0 to 2 pi, the first half has a positive value, the second half has a same value but negative. Add these two, we'll come up to 0. Okay? So the area must have a sign associated with it. That sign is determined by
under the x-axis.
f of x itself. F of x is positive area, f of x is negative area. So right now, what we just said is that once I get the limit, when delta x becomes very small, then that process appears, and this is called the definite integral. The integration from a to b, f of x dx, integration of f from a to b. This is the lower limit of the integration is a, the upper limit of the integration is b. This is the integration sign. This is the function to be integrated. This is the variable of the integration. This is the variable of the integration. This is not a multiplication. Just the same as we said that d by dx is not, I'm not dividing by dx. d by dx, f of x, I'm not dividing by dx. F of x dx, I'm not multiplying by, this is not a multiplication process, this is an integration over that variable. With me so far? Anybody is lost? Anybody is asleep? صح معانا؟ نعم؟ كل العيد بنلعب. خلينا بس الاول ايه؟ f of x dx. اوكي؟ زي ما عملنا implicit differentiation هنعمل حاجه في implicit integration وهنعمل substitutions وهنعمل كل حاجه فيها. يس. Again, if you do not know the graph of the function, can you give me a function that you do not know the graph of it? He's saying that I don't know the graph of the function. Can you give me a function that you do not know the graph of it, sine 1 over x? Okay? So right now, that's a good question because it's exactly my next point, is that not all functions can be integrated. Not all functions can be integrated. Integrability, so this is exactly the next one that we were talking about. If a function is continuous over the interval a and b, or if it has at most finitely many jump discontinuities, then the definite integral exists. If the function is not continuous, then I cannot evaluate that integration. And further to that, it's not always that I can find a closed form for the integration. So the function can be continuous, but I can find so for example, what about the integration of 1 plus x to the 4th? Square root 1 plus x to the 4th. If I give you that function, square root 1 plus x to the 4th, can you differentiate it? Can you differentiate it? Yes. If I can give you any function and you can differentiate. Differentiation, you can differentiate any function. Differentiation, think of it as like multiplication. If I give you any two numbers, you can very easily multiply these two numbers. Okay? Integration is actually similar to factoring. You cannot easily factorize any number. So for example, the number 247. Can you give me two numbers if you multiply them? It will give you 247? 247, yes. Huh? What? Other than 1. استنصح علينا. Huh? Other than 1, other than 1. What about 13 times 19? See, that was not very easy. That was not very easy to do. Okay? 13 is a prime number, 19 is a prime number. If you multiply them, you get a number that only has these two as a factor. Take a huge prime number like this, another huge prime number like this, multiply them, you get a number that is, you cannot even read. How can you factorize this? Factorization is not easy. But if I give you any two numbers, you can multiply them without a problem. Same, huh? Factorization, give me factors بتاعته. يعني 6 times factors بتاعت what's the factors of 6? 2 times 3 is 6. Okay? That's factors of 6 are 2 and 3. Factors of 9 is 3, because 3 times 3 is 9. Factors of 15 is 3 and 5. What's the factors of 247? Factors of 247 is what numbers, if you multiply them together, will give you that number. Factors of 12, 2, 3, 4, 6, because you can multiply 2 times 6, 3 times 4. This is the process of factorization. And again, it is not easy for big numbers. Yes, sir.
ايه الانتجريشن بروسيس بيساوي المساحه اللي اندر مساحه
انت كنت معانا فين بقى من الصبح؟ تعالي بقى في المكتب. This is exactly what we've been talking about for the last hour.
احنا جبنا السمشن بس ده عرفنا منين ان هو بيساوي الانتجريشن.
عرفنا منين هو بيساوي الانتجريشن؟ ان هو الهايتس بتاعت الريكتانجل. كل هايت بتاع الريكتانجل بيابروكسيميت الاريا دي. لو ادد الريكتانجلز الصغيره دي كلها تبقى ده يبقى جت الاريا. مش الاريا، مش احنا قلنا الاريا في الاول ريكتانجل.
لو معنى السمشن بتاعه ايه قلنا بقى السمشن بتاع الريكتانجل؟
السميشن بتاع الريكتانجل دي اللي هي كل بيز في هايت، البيز هو السمول انترفال، الهايت اللي هو الاف اوف اكس عند الانترفال دي. بيز في هايت يا اخوانا احنا guys if you talk while I'm answering questions I'm not going to answer questions. That means that the questions are not important. Okay? If you talk, if somebody asks me a question and you start talking, I'm not going to answer questions. So to show each other that your questions are important, listen to your question, your own questions. Yes, sir. Hmm? Yes. Okay. Actually, that is not correct because I didn't talk about any tangent. I did not talk about any tangents. Okay? Simply, very simply, any, whatever area you can think of, any area you can think of, I can approximate it by rectangles. Any area. And if I take these rectangles smaller and smaller, I will reach the exact area within an arbitrary accuracy. Any accuracy that I would like. If I would like the accuracy to be 1 to the negative 13, I can reach that accuracy by getting 2 million smaller rectangles. Whatever. If I have a formula for the integration, I can get the exact value for that area. If I have a formula, like in the case that what I started with, 1 minus x squared, I said that, if you remember, okay, remember this one? I can get, this is a formula for the integration. That means that this value that I got right here, 2/3, that's exact. The error here is what? 0. And when I went to the this is addition of rectangles. Okay, at 1,000 rectangle, this is 0.66. If I reach 1,000,000 rectangles, will be 0.6666. Okay, that is 2/3. معايا؟
ها؟
معايا يا اخوانا؟
لا
الفكره دي واضحه؟ area under the curve is the same as the definite integration. Yes, sir. نعم؟ Yes, you can differentiate any function, but you cannot integrate any function. I.e., you cannot find a formula. You can draw it as a function and substitute with the area for the small rectangles, but you might not be able to find a closed formula for it. Yes, sir. Continuous again ahead.
ممكن تكون continuous بس ما بلاش integration.
It does not have a closed form integration. Okay, again, the function that I just mentioned, integration of 1 plus x to the 4. This function is continuous. It's regular. The domain for that function is what? R. Okay? Function is continuous everywhere. I can plot it, I can divide it into smaller rectangles, I can get the value. But I cannot get it in a formula. I do not have a formula for it. Okay? ما اقدرش اقول ان دي تطلع ساين اكس ولا كوساين اكس ولا لين اكس ولا اكس سكوير بلس 4 ولا I don't have a specific formula for that integration. The fact that the integration quote unquote exists does not mean it exists in a closed form. طيب اخر حاجه هنبص عليها النهارده اللي بنبص عليها كل مره the order of the integration. If you integrate from B to A, is negative the integration from A to B. If I reverse my interval, the integration changes its sign. Integration from A to A is always 0 because this is a 0 area. The integration from A to B for a k times an integral, the k goes outside. The sum and difference, the addition of the integration is the integration of the addition, and the differentiation, the integration of the difference is the difference of the integration. Additivity, if I am integrating from A to B and from B to C, is the same as integrating from A to C. When this area plus this area is the same as the entire area. Min maximum inequality, which is very simply stated. If I have a function here over an interval, it has a minimum and a maximum. The area under the function itself is somewhere between the minimum of the function over the interval and the maximum of the function over the same interval. If I take the maximum of the function over that interval, take the area of that rectangle. The minimum of the function of that interval, take the area under the rectangle. The actual area of the function is somewhere in between these two values. Okay? If I take the minimum in that interval, the maximum, the actual area is somewhere in between these two values. And that's it. Any questions? We'll talk about this next time.